What does it do in soil? Well, we see that the earthworms, they have an effect on a lot of characteristics, but it will bring me to the roots part. The roots also have a very, very important effect on the soil. Have you ever seen that video? Are you sleeping? I talked to you about soil structural stability. Do you remember I talked to you about that about 4 hours ago? Soil structural stability. Now tell me, what does soil structural stability mean? It will tell you the capacity of soil to resist to water. More stable your soil is, more resistance to water it will have. Now, looking at that, which one is the more stable? The left. Because the water went through it and the soil particles stick together. So this is what happens when the soil is going through, when the water is going through the soil particle. Now, if I continue doing that and I put the soil in a real situation and we put rain on top of it, which one will be, how do you expect the more stable one to react? So you have, again, 2 soil samples. One is very stable, the other one is not. How is it, which one is the more stable one? Excuse me? Absorbs it. This one? Exactly. Because what's happening here is exactly what the first part of the movie showed. These soil particles, it all breaks, and as it breaks, it fills in the micropores of the soil, stopping the water from going through the soil. And then you'll get crusting and runoff. As in a very stable soil, the water is just going to go through. What can I do to get a better soil, a better structural stability? What does it depend on? It depends on the particle has to stick together. And so for it to stick together, it takes glue. And that glue will come from the mycorrhiza, the fungi that will produce glomalin that will stick the soil particle all together. Are you going to remember that name? Glomalin. Glomalin. G-L-O-M-A-B-I-L-E. Glomalin. And this glomalin is produced by the mycorrhiza that will live on the living roots. This glomalin will glue the soil together, but it has an effect of about 30 days. So once it's produced, the glue will be efficient for about 30 days, and then it will decay. Otherwise, we would just need to have a lot of roots, just a hay field, and then the soil will be okay forever. It's going to be effective for about 30 days. Once the living root dies, the mycorrhiza doesn't produce any more glomalin, and it will decay. Now, in a conventional, what is the part of the year where the soil is occupied by living roots in a conventional coarse soybean rotation? The summer. Just about 30%. In a conventional corn, bean, and wheat rotation, your soil is going to be occupied by living roots just about 30-35% of the year. Now, I need living roots to feed the mycorrhiza to be able to produce that glomalin that will stick the soil particle all together. So with the cover crops, we could get up to 80% of the year. And this is where we get into cover crops. And this is where, when I talk about cover crops, I will always say, plant as much as you can, as soon as you can, and let it go. So that all different kind of root system will get into place and will feed the mycorrhiza. Do you do that? 7, 8 species of cover crops at once? Are you going to try that next summer? You should. You should. On purpose, you're the boss. It's when the weeds takes over that you're losing. And one good thing about that is all the phenomena of water management, because we're always coming back to that 3D system. I want to have roots to have that glomalin, but at the same time, my soil will have a better structure, then the water management will also be better. There was an experiment done in the States, and they wanted to see the effect of a cover crops on the evaporation of the soil. They have very, very few water there, and they say that if they have a cover crops, they're going to lose more water than if they have nothing there. Do you agree with that? You're a lot smarter than these Americans. These two guys. So what they do is that they measure. So one thing that is very interesting is that when you have a cover crops, and I saw that last year when I was in the state, you have 87 degrees here, you have 107, and it's 2 fields right next one to the other. So the soil temperature is a lot higher, so the evaporation is a lot higher also. But what we have to look at is the impact of that soil temperature on the what's going on in the soil. At 70 degrees Fahrenheit, 100% of the humidity is used for the growth of your crop. At 100 degrees, 15% for the growth, 85% is lost through evaporation and transpiration. And so just the slides before, we had 107 degrees. We're up to there. We're losing a lot of the water available not to grow the crop. And so he did take these measurements, and what he saw is that in the, they had about an inch of rain on April 2nd and 3rd, and then up to June 14, no rain at all, very hot and very windy. And so the water capacity of that fallow was about 26% at 4 inches and 55 at 8 inches. The day after the rain, it goes from 26 to 29. It didn't make any difference at 8 inches deep because the soil was very hot and the water that came in just evaporate almost at the same time. Where they had that cover crop, they had at 4 inches, it was 75% still of the water available. So the amount of water that the cover crop is picking up is a lot less than the water that is evaporating where there's no cover crop at all. And so it has an increase at 79%, and yet at 20 inches deep, still we had, the water just got into that deep. So the roots, not only does it help working on the soil stability, but it also works on the water management. And this is where you have to choose the roots that you're going to be working with. I like a lot to work with a lot of different roots, but I'm going to be choosing the roots that I'm going to put in with respect to what my soil needs a lot. Are you using tillage radish? Very spectacular plant. Very, very spectacular. It is programmed to produce that kind of a bulb, a carrot type. So when it grows, and if it encounters a bit of compaction, it will keep growing, but then it will get out of the soil. The first time we did that, 4 years ago, I had a producer. He called me in the fall. I want to see you. I want to show you my tillage radish. I went there. The whole field was 10 inches out. It was 10 inches out of the field. He looked at me and he says, if I go on top with my tractor, do you think I'll go down? See, I have an engineering degree. I'm not sure I should answer these kind of questions. So this is why I say this is very spectacular, but yet if you have a very big compaction problem or a very heavy clay soil, you should work with a plant that has a lot more roots, very, very, very many roots, thinner roots that will get into every cracks of the soil, that will get the mycorrhiza to grow onto it, and that will produce a lot of glomalin that will tie the soil particle together, and in a few years, you're going to get into tillage crop, tillage radish, and it's going to be a lot more efficient. And the cover crops permits you to work, to do very many things. I have producers that use tillage. They will grow 2 rows of tillage 30 inches apart. And these tillage are exactly positioned where the corn row is going to be the next year. And in between, they have a mix of legumes, cereal, and crucifer. And so you can build your soil this way. At the springtime, where the tillage is, there's nothing left. It's perfect for to put in the corn. This is not too bad. This is impressive, right? But it's local. Are you doing some intercropping in corn? Are you doing some intercropping, that cover crops in between corn as the corn is growing? We did that that's the 3rd year we're doing that in that field. And what we see is that usually when we plant something in between corn, we're a bit scared because we want the corn to have everything to him and just the leftovers for the cover crops, right? That's the way we think, isn't it? You don't think anymore at this time. I'm talking alone. I just have to fill my time. So when I come back to my work, I said my boss, I talked to them for 3 hours. None of them were listening to me, but I did it. So this guy, what he did is he modified his cereal planter, and we have 3 rows that are planted. I really suggest to every time you can, if you can plant the cover crops, then you're going to have the best germination, and you're going to have the best germination. The best germination the first time, and the second best germination, meaning that what's not germinating now is not going to be germinating next year, where you don't want it to be germinating, right? So I planted there, and in that field, it was planted at 9-leaf stage. And so at the end of August, it's pretty discouraging. You put a lot of effort, you put a lot of money into it, and yet you didn't get much out of it. And even when it's going to be harvested, this is going to stick small. But what we did is we did the same thing. These are the 3 rows. It's a 6 to 7 species mix, but it was planted at a 3-leaf stage. Very, very short. And because it's planted in between, so we don't have that competition that we're afraid of right on top of the row. And because it's planted, well, it's germinates slowly, and the corn has that head start that will prevent any yield loss. And this is what we saw for 3 years. It's very amazing. This is in August again, and the corn is really well standing. His father, he told me his father, you know how guys are when something's going wrong. His father did that. So his father went to plant the corn, and it took him 200 meters to saw that the planter was not working. But it was good at the end because we planted the cover crops, and what we see here is that the cover crops really take a lot of places and they really grew very tall. But if I get in the field, just about 2 rows aside, this is how it looks. So it really shows that the corn head start really made a difference on the cover crops growth. But if you plant the cover crops soon enough, you can still have a very good canopy, and it's going to help a lot with all that roots living system. It's going to improve the when the harvester is going to get into it, that the soil portable, whatever. It's going to be a better.
And no yield reduction.
No yield reduction.
I find that hard to believe.
It is, but it's the fact. I'm going to keep doing that to more producers, but there was no yield reduction, and with time, we're getting a lot better because the soil quality is getting there, and that nitrogen efficiency is getting there, and once you go in the soil, the compaction factor is less important as well. Economics of it.